So homework 4, part C, question 1. We're going to be creating a Moody diagram of friction factor for Reynolds number with the ranges given and using Churchill approximation, the Colebrook-White equation. We're going to start by importing numpy as P, and then from our plotly.subplots, we will import make subplots. So then we're going to define our Churchill with our RE and ED. And that's going to be using T1, T2, and then we're going to have a result. Not a result, sorry, a return using the Churchill, or using the F equation. So I have our equations written down. Theta 1 is going to be equal to negative 2.457 times the log of 7 over RE to the 0.9. NP dot log. And then, so that's that one. Make sure I'm still recording. Okay. So blue, parenthesis, and then plus our 0.27 times our ED. I think I have, yeah, this is right. I have one too many. And then that's going to be to 16th power. And then our theta 2 is a little bit shorter, 37530 divided by RE to the 16th as well. And then we're returning our 8 times E over RE to the 12th plus our T1 plus our T2 to the negative 1.5 power, and then that whole thing is to the 1 over 12. Let me reread this to make sure. I think that looks right. So then we're gonna have our RE as our NP dot log space, and that's gonna be for the NP log 10 of 600, 8, 100, and then we're gonna do EDS is the same thing, log space, except for -6, NP dot log 10 of 0.05, and 100 as well. So then we're gonna do fig equals make underscore subplots. And then that's gonna be for E, D, and E. And then we're gonna do our fig dot add scatter, and that's gonna be doing x is equal to the Reynolds number, our y is equal to the Churchill for our e, and the EDS. And then we're gonna select our mode as being lines. Oh, we're doing that. Jeez. Okay. And then we're gonna do our x-axis, and we want this to be in log form. And then we're going to copy and paste this and do the same thing for y. And then we're also going to update the layout. Update layout. And then we're going to say that our height is equal to 800. Our width is equal to 800. And then we'll say our template is equal to Plotly underscore dark. All right, so now that we got that fixed, I was just missing something small, so we got that updated. Moving on to question 2, we'll be writing a Python function to calculate the head drop. Given the variables and testing for given variables as well. So we're going to start with g is being equal to 9.81, rho is equal to 1e3, and then mu is equal to 1e negative 3. All right, and then we're going to do def head and then relate it to q, l, d, and ed. We're going to write v as being equal to 4 times q divided by np dot pi divided by d squared. We're also going to say that this is equal to rho times v times d divided by mu. And then we're going to result, we'll do a result for our Churchill function. So result for Churchill RE and ED divided by gravity times RL over RD. I think I have one too many. Times our V squared over 2. Okay. And then we're gonna plug in our variables doing, or using 100, 0.5, and then our ED as 1e to the negative third. Oh. return result. Okay. All right, so that is going to be what we consider our head drop for part 2. And then writing a Python function to calculate the flow rate given the head drop, pipe length, and diameter. Test your function by doing the reverse calculation of C2, where the head drop is set to that calculated from C2. So we're going to do the from scipy.optimize. We're importing root function. Oh. Alright. And then for this one, it's going to be def of q with, we're going to do our dz, our l, our d, and our ed, I believe. And then we're going to define the Bernoulli using q, l, or no, not q. I think it's our v, our l, and our d. And then we want to do our RE here, and then we'll return a value. And then we're gonna do a guess, nope, and V equal to, and then another return. All right, so oh, this has to be E, D, and this one we're just doing for V, not L and D as well. So our Reynolds number is going to be rho VD over mu, rho VD over mu, and then we're going to be returning our DZ minus our Churchill using the same equation that we did prior. So that's DZ minus our Churchill for our REED divided by G times our L over D times our V squared over 2. That looks like there's an extra one here. And then we're gonna guess with our times our G times our D, and then that's gonna be divided by 0.5 times our L I'm missing a parenthesis here. DZ2GD. This is divided by L. L. It was divided by, I think. Okay, that looks right. And then our v is going to be the root of Bernoulli and our guess. So v is going to be the root of our Bernoulli and our guess dot x. And then we'll be returning in the pi, let's see, np dot pi times our, oh, not squared by that, times d and then we do our q and we plug in what we found earlier for our q, and that's gonna be our 027 or 1027 point, we're gonna round to 9, and then this is, the length is 100, and then our diameter I think is 0.5. And oh, this is supposed to be 4 times v, I think. Okay, and then that's close enough to 1 for me, so we are going to call this homework wrapped up.